today's lecture we are going to see the continuation of the lecture what we discussed yesterday. Discussed that what kind of geological features or the changes a river erosion is doing in the surface of our earth. Okay, so if we see that the processes which are done by the erosion processes, what are the processes? Which includes hydraulic action, abrasion and attrition, three main processes, and chemical action is the next process, corrosion processes. So the hydraulic action and the abrasion processes together at the initial stage of a river, it produces one landform or produces a feature. That feature is called potholes. Potholes means it is the shape of the hole is the depression which is making by the river is something like a pot. I'll tell you that how it is happening. This is a river surface through which the water flows, and the writing here it is a bedrock. Bedrock means it is a solid crystalline or solid hard rock. So the water which is flowing over this hard rock surface, what happened? There would be some kind of surface features or some irregularities on the surface of this rock that will peak by this water. Okay, so as a result, what happened? There is a small depression which formed on the surface. A small depression which formed on the surface. Now this process is mainly done by the water only, so we call it as a hydraulic action. Now what happens after this formation of a small hole? There may be some small grains. Grains means there are the sediments that may enter into this small depression, and water is still again flowing through the surface. As a result of flowing of this water which is getting into a small depression, there would be small circular movements will take place. Initially there is a very small process of a circular movement, and that circular movement will take place, and this will increase the depression. So when it increases the depression means the process now it is water along with the sediments, so that together will increase the depression or the cavity which is formed on the surface. Now again when it increases the depression, then the more amount of sediments will trap into this depression. As a result, what happens? The erosion in the bottom part will larger compared to the neck part. So as a result, when we go down, the depression on this part will be, the cavity on the bottom part will be high compared to the depression on the contact between the water and rock. As a result, when we see the depression, it will be something like this. It will have a narrow neck, and it will have a wider bottom portion. So this structure, what it is formed by the river, is called a pothole. So these potholes in later period by the process, this will become wider and wider, and it may go deeper and deeper, and it is actually a process of a erosion process of a river, and that we call it as the first feature. It is a pothole. Okay, so that is first feature. Now the second feature which is produced by a river is a river valley. As you know that the rivers are flowing through the defined channels or the valleys. So if this is the surface, if you see here, this is the surface through which the river is flowing. At the point when there is a large amount of water by rainfall or an ice melting of ice, the water will start flowing through small channels. So these small channels we call it as gullies, rills or gullies, because these gullies are not permanent. This will come only during the time of high water influx, so it will be there for some period of time. Then after the monsoon, after the rainy season, these gullies will be not having water. But these processes of gully erosions will subsequently lead to a channel formation. Now what you are having here, these channels, small gullies which are formed, now it's are connected, and now these channels are formed. So this kind of channels will produce a streams, and this well-defined streams flowing through a depression, we call it as a valley. So all our rivers which are flowing through these valleys in a definite channel. So here if you see, this is a valley in a bedrock channel. Okay, and these valleys will always have the different processes. Number one, the process is the downward cutting. So the valley will be more deeper and deeper as the time goes on. Okay, so this we call it as the deepening of the valley. Same time, there would be more number of gullies it will be forming, and this will be increasing the length of the channels or the valleys. So that process we call it as the valley lengthening. At the same time, this valley which is forming now, right now the water is flowing on this valley, this will increase the width also. So that process will also happening. That let us take an example of this river system, correct? So this is the same river what we have discussed yesterday. Now where is the valley on this river? The valley is, if you see on the bedrock part, the river which is flowing through the valley here. So if I take a cross section across this, so we can easily see where is the valley. So the water is flowing through here. So this is the valley through which the water flows, correct? If you come into the lower reaches where the floodplains are there, I'm little bit extending it towards the hard rock or the high terrain so that you will be able to understand the topography of this region. See, where is our valley? Our valley where the water flows is here. So the water channel is still smaller. Now I'm exactly on the water channel. The cross what you are seeing here, it is here, but the valley is wider. Okay, and it comes down to the more wider, then it comes down to the high terrains, high regions. Okay, so this way the channel. So this part, there are, what are the actions which are happening? The depth of the valley increasing by the flow of water, the width of the valley increasing, and if you go into this particular part where the valley is, the water is contributing. Okay, so here if you see, there is a small stream, this joining, and if you see the stream will be somewhere, it will be increasing its length also. And as a whole, the drainage basin, what you discussed in the last lecture, the drainage basin is where the water will be collecting by a river. So that process we call it as a drainage basin. Now for this particular river, if I see, there are two rivers. One we can see here, this is Narmada river. If you are able to see the cursor which is moving, this is the Narmada river and this is the Tapi river. Where is the drainage divide? The drainage divide is the hills what we are seeing here. So if I zoom the hill here and make a 3D view of that, you are able to see there are two rivers. Okay, so one river which is Narmada on the left hand side and Tapi on the right hand side. Narmada is now flowing through the hard rock and Tapi is now flowing through the alluvium. The hard rocks are much higher. So there would be small channels which will be developing on this this area, and it may come into one point of time this upward cutting of this Tapi tributary will reach here. Because of the large amount of height difference between Narmada channel and the Tapi channel, the flow of water from some tributary may took towards the Tapi. So this process we call it as a river capturing. Simple process. One channel from Tapi, there is a channel that we can see. This channel is now extending its length. Now it's extended the length up to the top of the hill. Now there were another channel which was flowing towards Narmada, but what happened, this both the erosion processes mixed together, and a result, if I show you in the presentation what it will happen, there are one river which is flowing here, another river which is flowing here. There is a tributary means a small stream of this river which is cutting this hill. Okay, now it reaches here, and there is another tributary which is cutting this hill. Now what happens, this hill it cuts up to here, now this hill cuts up to here. Now this both of the cutting of the river joins together, and the water from that one river either flow on this way or this may flow on other side. So either of this will happen. Now these are two directions will change. Now water from this river or this channel will flow completely to this river. This process we call it as a river capturing. So this kind of things are also possible in the system, and this is not a very simple process as the way I'm explaining. This is also related to the changes in the topography, tectonic activities, shifting and slitting. So that is the process of river valley. Now the next is the river valleys. There are two type of river valleys, and gorges and canyons. Canyons are large, deep river valleys which are having a specific type of river valley which are having a horizontally stratified sedimentary rocks or the rock types. So this we see these all rock types are horizontal, perfectly horizontal rock types. So this we call it as a canyon, and the gorge is a gorge, and both are same, but canyons is a special type of that where the rocks are horizontal. This is a gorge. It's a large, steep, eroded valleys produced by a river. Now another erosional feature, what we call it as a waterfall. Waterfall is also a erosional feature. For example, if you see here, now the river is flowing on the surface, and the river is flowing through the surface of two different layers. This is one layer that is called S, that is limestone. Another layer is called shale, and below that there is another layer that is again shale. Now when water flows through these three different varieties of rocks, water will have different action on these different rocks. For example, this will be slightly more resistant, or more erosion processes are acting on one kind of rocks. As a result, what happened? There would be a differential erosion process. So the water which was flowing on this part was completely removed very quickly. So as a result, the surface now becomes something like this. So there would be a change in the height. Okay, this much change in the height. So water will start flowing in into this height difference. So this we call it as a waterfall, and waterfall is also another process or another landform produced by the water or running water. There are a number of reasons. One process is the difference in the property of rock, and there are other reasons. There may be some kind of structural features. We'll study it in later phase. There may be a fracture, and this block has moved down. So now the surface is something like this. So here it will produce a waterfall again. So that kind of different processes are again possible in the case of a river system. So this is the fourth feature. Then last one, it is a stream terrace. Stream terrace is again a erosional feature. If you see here, this large part of the river, we call it as the river valley. But where is the river now? River is now flowing here. And what is this step-like things? This step-like things, what you are seeing here, T1 and T2, we call it as terraces. So terraces are produced by the erosion activity of the river. If you remember my last lecture where I have said that river will be shifting within this valley. If the valley is in alluvial plain, it will be major shifting. And if it is not in alluvial plain, if it is in a gorges or in the hard rock terrain, then the lift shift would be limited, but still the downward cutting will produce some kind of terraces. But here I'll show you another. For example, I'm taking the same example. Here this is our Narmada river. So Narmada river, what I'm going to do is that I'm going to take a cross section across this river. So here this is the cross section of Narmada. Let me take it perfectly on this plane, alluvial plane only. Okay, now if you see here, what you are able to see, this is a elevation difference. See, the elevation here is 20 meter and here it is 30 meters. So there is a 10 meter elevation difference in this part. Okay, but here the elevation is 10 meter almost flat, and where the water flows here. Contrasting with that, in the opposite part, if you see, there would be another. So these terraces here are getting terrace 1 here, and T1 here, and terrace 2 here. But here we are getting only one terrace. We are not getting the perfect signature of the this contemporary terrace. But that we will get in other part. For example, if I make a cross section here, Now you see the cross section, what you are able to see. We are able to see the Narmada channel. On the channel, this is an island, and here we have one terrace and we have another terrace here, and we have another terrace here comparatively higher than this, and we have another terrace here at a 20-meter elevation. So this terrace is more sloping because of the sediments which are contributing from this, and there are a number of other rivers also, so that they are cutting. But if you generally take this height, that becomes somewhere around 20 meter, and there is one more level on the right hand side. So this kind of processes that we are producing, what we call it as the terrace. And if you remember my first lecture where I have discussed about the Wasat bridge, where I have discussed that the buildings which was created, and all that buildings they have created in the first terrace. That is what the trouble what they have done. That is the terrace one. That is the recent terrace. And the bridge where we are right now connecting that bridge, that is in the terrace 2, and that is very occasionally water can reach up to terrace 2, or it is only possible in a very high floodings, and in the terrace 1 it is a very normal, very active part of the river. Correct. So that is the terrace. Now erosion processes we have seen, erosion features produced by the river, what we have seen. Now the next is the transportation process. Transportation process means when the river erodes something from the surface, now that material needs to be transported to the lower part of the river, or the downstream side of the river. So that transportation processes have done by the river in 3 categories. That 3 categories are called the bed load, the suspended load, and the dissolved load. What is these 3 types? Bed load is means the river is plucking the large sediment, but it is not able to pick it from the surface. As a result, what it will do, it will either roll the sediment, or the rock, or small rock sizes, or the gravel size particles, or it will slide the material, something like this. Okay, so it will either roll the material, or it will either plug the material, slide the material, or it will jump if it is something able to the jump. So these 3 processes will be happening, either rolling, or sliding, or jumping. So this jumping process we call it as a saltation process. So these 3 are the main processes by which the river transport material. What you see here is the rock surface, and this is the water level. We are seeing a cross-sectional view of the river. So these processes, 3 processes, what we do, this is called a bed load. It is done by rolling, sliding, and saltation process. Then the rivers will transport some material in suspension. These smaller materials what you are seeing here, these all are the suspended materials. Okay, that remains in suspension. That the size of the particles are small, so the river is capable to get it from away from the surface, to pick it from the surface. So it pick the things, and it will transport within the water, which will be transported as a suspended load. And the third one, it is the dissolved load. The dissolved load is what we may not be able to see the grains, but when we filter the water, we will be able to see the materials which are dissolved in the water. So these are the 3 different ways the sediments transport by the river. Now erosion and the features and the transportation, what are the different mode? But and the third activity is the deposition. Transportation doesn't make any features, it rather transport one material from one part to another part, but the deposition of the river which makes different features. Okay, deposition means all these materials which are transporting either in suspension, or in bed load, or in dissolved load, it will be depositing somewhere in the course of river system. Ultimately everything will be depositing to the sea, but in between there are so many other areas where it will be depositing. For example, if in a flood, if you see that the flood water coming into our regions after the flood retreat, if you see there would be a thick layer of sediment depositing, what we clean usually after the flood. So that is a sediment deposited by the river. So that materials mostly remains in suspension. This bed load materials will not come. That materials comes with mostly on suspension material. That is what the fine clay materials what we get in the get after the flood. Now, deposition of a river which starts from the headland region to midland region to the mouth region. So this deposition will be happening in different regions. One we call it as an alluvial fans. So alluvial fans are cone-shaped accumulation of stream deposited in the base of the hill. And floodplains is in the middle region where the sediments depositing on either banks of the river. So there are three different varieties of floodplains, either convex, conveyed, and there is one feature we call it as a natural levee. This is a comparatively elevated surface towards the river. Then there is deposits within the channel that we call it as basically bars, sand bars, or sometimes it is a point bar, sometimes it is a channel bar, or sometimes it is a island. Or last one, it is the delta, which is depositing at the mouth of the river. Okay, so we are going to see one by one. First one, we are going to see an alluvial fan. So alluvial fan is something like this. Okay, so this is the hilly terrain, and if you want to see the hilly terrain here, we are right now in the Himalayan terrain, where the Himalayan, because the other part in Gujarat and other part, we are not able to see the alluvial fans right now because these all alluvial fans are now below the floodplain. So the floodplain sediments, the loose sediments, or the overbank deposits, or the flooding deposits, which are all covering the sediments, so all these things are below the surface. We are not able to see. But in the Himalayan rivers, if you go, we are able to see these alluvial fans. What you are seeing here, this is Indus River flowing on the Leh. Leh is a well-known tourist place, so I hope you all understand where the location of Leh is. If you see on our Indian map, okay, so this is the map of our India, and we are here somewhere in the Himalayan terrain and the Leh Valley. Okay, so Leh Valley, if you see these are all sediments which are, okay, these are all the sediments or the water streams which are flowing from the hilly terrain, and when it flows to the hilly terrain and after it ending here, so it is depositing most of its sediments which are transported by the river at the foothill. This is the part where the valley starts. So this is almost a plain surface, and when it reaches the plain surface, the river is not capable to carry all these materials. As a result, what will happen? The river will deposit all these materials in the front part of the hilly terrain. So see, all these deposits are depositing, and as a result, this is the river which flows, but these surfaces are formed by a alluvial fan. So we sometimes call different terminologies for this. We call it as if the slope activity is more, we call it as a colluvial fans. If it is river activity is more, and we call it as an alluvial fan. So a number of different terminologies are there, but ultimately the process is the large amount of sediments which are transported by the river are depositing in the foothills. See this part, if you see, this is a very good alluvial fan, and I hope you are able to appreciate the different generations of alluvial fans also. Now you see this river which was flowing here, now it started flowing on this panel. So it is like the river which is waving from one end to another end. The movement of river is there. Okay, river must be flowing somewhere on this part, now it has started flowing on this part. So number of areas where it is changing the path. So this process, this is called a alluvial fan. We can see that in the Leh Valley, there are number of alluvial fans are there. All these small tributaries which are contributing the river, everywhere you are able to see the alluvial fans. Some of these alluvial fans are already stabilized. Stabilized means there is a growth of plant. See, this is a very fertile land, so people started using it for some kind of cultivations, or it is a normal grassland or something like that. Okay, so this processes are, so this would be an older one, and these are all active alluvial fans. So this is one feature. Second one, it is a floodplain. To see the floodplain, let us go to our area, Narmada only, where we have already seen. So that is our floodplain. See, this is the area where the Narmada river is flowing out of this Kevadia colony, and all this part we call it as a floodplain. Floodplain means is relatively flat land, and if you see Narmada, then there is another river. This is our Mahi River, then we have Sabarmati. So all these rivers together, it makes a floodplain. And if you see the elevation or the cross section of all these rivers, we can see these are almost flat terrain. See, the variation of the height is from 40 meters to see the around 30 meters. So all this area, this is around 83 kilometers what you are looking at, and there is only a 10 meter difference in the height. So that means this is almost and one river comes here, another river comes here, and third river comes here. So this flat, almost flat land which is produced by all these rivers together, we call it as a floodplain. And within this floodplain, all these rivers are changing its path also. If you want to see how it changes the path, so this is another river. This is in Bihar, Koshi River. You must have heard about the Koshi River, and few years back during a high flooding season, the Koshi River have completely shifted its channel. So this is the scenario of Koshi River in 1984. It was something like this. It was flowing something like this. And in 2018, if you see, you can see that there is a lot of changes in the path of the river. See, look at here. This is one point bar, 1984, and this is now detached, and there is a new channel which formed. See, the river is flowing only single channel. Now 1884, if you see that it is flowing on different channels. So this kind of lot of changes are actually happening in the river. So if you see the series of changes what it is happening on this river, just look at the stream. So how much changes are there? There are so many areas where changes are happening in the river system in a time series base. Okay, so this is around 40 years of story what I am talking about. Now we can imagine the life of the Earth's surface. It is 4.5 billion years, and large to so many millions of billions of years, the surface processes are changing, and this is actually creating lot of topographical changes in the surface of the Earth. Now another important feature, and I talked about this we have already discussed. So this is the river, and the area where adjacent to the river deposits the sediments during its flooding. We call it as a floodplain. And natural levees are slightly elevated points on the floodplain towards the water. So this is a river channel. If you see, this is a river channel, and this surface, what it is slightly elevated than the nearby floodplain. I will tell you why is this, because when the river flowing through and river started overflowing the banks, what happens here in this part, there would be a large amount of sediments in suspension or in saltation. That sediments will be there. So river will not be able to flow it with that same energy what it is having in the channel at this part. So as a result, what happens, it will deposit the sediments towards very closer to the channel, the river channel, existing channel. So as a result, that becomes slightly elevated, and it will go away from here. The size of the sediments and the amount of the sediments decreases. So as a result, it will become gently sloping away from the streams, away from the channel. So this part we call it as a natural levee. So this natural levee is, there are artificial levees also, what we prepare when you study the irrigation. You will study the levee that would be constructing in the canals. When you construct a canal, the banks of the canal we slightly elevate from the nearby area so that the water will not overflow immediately. So that we call it as artificial levee. So we'll see the designs of that in the later. Now one feature what we are to discuss is the deposits within the channel. Deposits which are happening within the channel, we call it as bar deposits. Okay, so bar deposits are the amount of sediments which are depositing within a river. For example, if you see all rivers, any river if you take, you will be able to see that. If you see that this is a bend of the river, okay, and this river is bending here. And yesterday, if you remember that the flow velocity should be maximum towards this end where the river would be cutting, and the flow velocity would be minimum on the towards the curvature. As a result, what happens, the river will start depositing on these bends. So the river which is depositing on this curve, inner portion of the curve, this deposits, we call it as a point bar. We call it as a point bar. And if these deposits are forming sides of the river in a straight line, we call it as a lateral bars. Okay, sometimes the lateral bars would be having an alignment which is perpendicular to the direction of the flow. We call it as a transverse bars, and the longitudinal bars, something like that. And if the sediments are depositing within the channel, we call it as a channel bar, and if it is stabilizing, we call it as a island. Okay, so islands are formed, channel bars are formed, point bars are formed. So now this was formed as a point bar, now this is now converting into a land. Okay, so here we can see there is a deposit, channel bar deposition is here, here it is a point bar deposition. So that kind of deposits are also happening in the case of a river system. And last one, which is towards the mouth, the river will be depositing the delta. So delta is all the sediments. If it is not able to deposit any of the sediments in the alluvial fans, or if it is not possible to deposit the sediments in the channel, or if it is not possible to deposit the sediments over bank, then ultimately this will be depositing in the delta. Okay, so we have discussed about the deposits in the foothills, deposits within the channel, deposits in the overbank and the floodplain. Now, one last thing about the river, that is oxbow lake. Second last thing, oxbow lake. River meandering, and oxbow lakes. These are the results of river erosion process. This is a feature produced by the river. River meandering is nothing but when the velocity decreases from the slope decreases, the river will not be able to flow in a straight line. As a result, the river will take a curved path. So this curved path produced by the river, we call it as a river meandering. So the same single river, if you see here, Narmada river I am looking at. So this Narmada river in the upstream part, it is flowing through a straight channel, and when it comes to the lower portion where it is, this is a floodplain. Okay, when it comes to a elevation difference, and as a result, what happens? The river now started flowing into an almost flat land, and it is taking these curved paths. Okay, these curvatures, these are taking. These curvatures which are taken by the river, we call it as a meandering. So this meandering, sometimes what happens, this meandering or the curvature of this meanders increases. For example, the same Narmada river, I am looking at Madhya Pradesh, in somewhere around Hoshangabad. Okay, so here if you see, this is a meander, same meander. Okay, meandering river. Now this meandering river is flowing here, and if you look at this part, what you see here, you can see a small channel here. Okay, so it is what a older channel. So once upon a time, the river was flowing something like this, and it started cutting, and as a result of continuous cutting, what happens after some time, the river started flowing through this channel. So this portion of the channel which left out, so this meandering which left out by the river sometimes remains some amount of water, stores some amount of water. So this water which storing in this kind of left out channels, we call it as a oxbow lake. But we call it as a oxbow lake. So oxbow lake is a channel which produced by, or a lake which is produced by the meander cutoff. Okay, so earlier the river was something like this, flowing through a curve or a meander, and this meander neck which reduces its width slowly. It took so many years, and once upon a time, in a case of a major flood or something, the meander neck will completely cut and it started flowing straight. As a result, what happens? The river started flowing left, straight, so it left a curved path, and that curved path we call it as a Oxbow Lake. So that is again a river feature. Basically, we cannot say it as a depositionate feature. It's a river feature, and this meandering and Oxbow Lakes, I'm putting it here in the river depositional feature, but it is a river, large scale river morphological feature.